All right, so it's a couple of minutes past the start of the hour, so let's get started. So everybody, thank you for joining us today. This is Mark Schaefer. I am the project manager from iNEMI. This is the call for participation on the Extended Reliability Assessment for Electronic Components, Phase 1. And the project leader is Juan Dominguez from Intel, and he will be our speaker today. I do want to remind everybody you are on mute. If you have a question, please type it into the chat window. Use the raise hand function, and I will get to those at the end of the presentation, though I will try to monitor the chat. So if there's a question that's pertinent to what's being discussed at that time, I will try to break in with that, but otherwise I'm going to hold all the questions till the end. We do have an hour for this session. I think we'll be able to get through the presentation and have reasonable time for questions and discussion after that. I did put into the chat window the link to the project page, which has the SOW and the project statement for this. And there will be an email that will go out to everybody that is registered with that information later this week. But with that, let me turn it over to Juan. So Juan.
Yep. Thank you, Mark, and thanks everybody for joining us. So as Mark mentioned, today basically we're doing a call for participation. If your company or somebody in your company or somebody in your network that would be interested in joining this project, we would greatly appreciate reaching out to them. And also, I mean, if you have any further questions or want to clarify things, even if it's not in the meeting, we can also do that offline. So yes, I mean, we need more people, we need experts, and we need the team to help this project, which we think is quite relevant and quite important given the current climate for electronic components. So with that introduction, let's just get on with the presentation. So what we are proposing here, this is a project that we have been working with several other companies, as you will see in the next slides, for quite some time now, is the extended reliability assessment for electronic components. So basically, our goal is to understand the actual or extended reliability of an electronic component, which could be typically, or it could be different than their standard shelf life. And we'll provide the background on why we're doing this. It's basically for to enable a circular economy principles. And we have broken this project into 2 phases. And right now we're just calling for participation on phase 1. So on phase 1 is more of a methodology assessment. So we want to come up with a methodology on which electronic components or parts to select for this study. This could be based on the type of the part, the reusability, criticality on a system, their carbon or energy footprint. And then the other part of phase 1 would be test and stress methodologies. So this is where we look at how the stresses are done currently for electronic components. These are not in systems, but separate from a system. And what we would need to test them to understand extended reliability. Would it be a stress to fail? Well, what kind of pass-fail criteria we need? What kind of processing or pre-processing needs to happen to understand the effect of that processing on the part? We need to come up with that methodology. So this call for participation is just for phase 1. And then for phase 2, if phase 1 is successful, then we would run a proof of concept where we have this part selected, we have a methodology for testing and stressing, and we just collect the data that we need for assessing the reliability of the parts. So this is a technically oriented project as we have it here. Okay, thanks Mark. So yeah, this is the we have worked on a statement of work, which was approved by iNEMI, and these are the companies that have worked with us, as you can see there. So quite good contribution. Yep, next one, please. Okay, so we have a couple of background slides here. So the first one is the driving forces for this project. Excuse me. So on the top left side, we have seen, given the explosive growth in electronics that has carried a large waste and carbon footprint that it's quite difficult to deal with at the moment. As you can see, and probably in some other documentation, there are a lot of places that have a lot of electronic waste, which is difficult to dispose of, and in some cases could be harmful to people. Then on the bottom left, this is a nice graph from Microsoft. This shows basically the carbon footprint or carbon scales for manufacturing parts for electronic components versus the usage of those parts. And it's quite clear at the moment that the manufacturing of the parts has a much bigger carbon footprint than the actual use of the parts. So leveling those planes or understanding better how to optimize those scales is part of our motivation. Then in the middle, we have a report from EEA, European Consortia, where there was a question that was asked to customers on the desired lifetime of a part, which is shown in orange, versus the actual lifetime or the warranty lifetime of the part. And you can see, I mean, this is a little bit of a section of that graph, which comprises the electronic components. But you can see many folks that responded to this prefer a lifetime, or the desired lifetime is almost twice as long as the actual lifetime from a part. And if and you look at the mobile phone, it's about 3 years, and people would like to use it for 5 years, for example. And then lastly, we've seen a change in the political environment. Of course, without getting into the politics and so on, we have seen recently current U.S. government signing an order for right to repair. So some of the methodologies and background here would help in that area. So all these different motivations are basically pointing to the fact that we need to better understand optimal part electronic component utilization. Okay, so I'll stop here. If any questions.
Yeah, if you've got any questions, I would ask please use the chat window or the raised hand function.
Okay, then we'll.
At this point, I see none, so let's move on.
Okay, sounds good. Okay, so additional kind of concepts for optimal utilization of electronic components. This is based on a UN IRP environment report that came out last year. And basically what the UN environment defined here were very interesting concepts. You have the end of life, which is the expected overall lifetime of a part. So this is not just electronic components, it could be any type of manufacturing. Then you have a end of use. So this is when a part would be expected to be replaced, for example. And I mean, for circular economy, the end of life and end of use ideally would be the same. So here the graph from the UN shows on the top is the new manufacturing. So any manufacturing, this is basically maybe 99% of the parts that are manufactured these days. So it's manufacturing, and then there's basically expected end of life. So these is the reliability assessments that are done on the part that can, with some reliability models that tell us the part could last for 3 years, 5 years, or something like that. But then there's some new manufacturing that is coming up. So we have remanufacturing and we have refurbishment. So in the remanufacturing flow, we have also an expected end of life. But then when that happens, then there's a remanufacturing for, say, replacement or getting new parts in expectation of the fail or something like that. And then continued use of the whole overall system, which is the expected end of use, and then the actual fail of those parts. So you can see that this almost doubles or triples the lifetime of overall system. And then finally, there's the refurbishment, which we have an expected end of use of a part, and then end of life, which is longer than the end of use. And what we're trying to understand here is what are these end of use versus end of life differences, so that would enable remanufacturing and refurbishment, or even just manufacturing for with a longer expected end of life. So that's kind of the crux of the project. I think I saw a question there from Kelly, perhaps.
Sure. So Kelly, let me unmute you and I'll let you ask your question. Hang on. All right, Kelly, you have control of your mic.
Okay, can you hear me now?
Yes.
Great, thanks. Hi, Mark. Hi, Juan. My question is around the term components or even parts, and just for a scoping question, and I understand this may be in the statement of work or other literature supporting this project, but what are you including in that definition or description of electronic components?
Yes, that's an excellent question. So yeah, I mean, basically it would be electronic components for systems. So we have proposed classifications such as actives, passives. I mean, within the actives, we have integrated circuits, memories, and so on. And then in passives, you have capacitors, resistors. And then, of course, you have printed circuit boards and mechanical parts and cables and so on, which we have proposed to be out of scope. So for the most part, would be electronic components that have either passive or active function on the system.
Great, thank you.
Yep, no problem.
Any other questions at this time? If so, please use the raised hand function or type them into the chat window. Okay, seeing none, move to the next slide. You can do your best, Al Pacino.
Yep, so this is the bathtub curve for reliability. I mean, basically, background on this one is that electronic components are typically tested to certain standards, JEDEC or IPC, and so on. And then the bathtub that is shown on the top right, that's fail rate on the y-axis and time on the x. And the fail rate is high initially, and then it kind of levels out, and then it starts up again. What we are trying to understand here is what are we actually testing when we do reliability testing using these standards for components. So is it right at the beginning of a bathtub? Is it near the end of the bathtub? And if we can bring those in closer, or we can bring them closer to actual reliability, then we could use the component more optimally. And the bathtub at the bottom is just reliability, not very extended reliability that somebody could think of. So we're trying to optimize their reliability. So we have three scenarios that we can think of here. So one is where we have a reliability that is lower than actual part reliability or warranted part reliability or marketed part reliability. I mean, there could be economic loss based on just the fact that the part has to be replaced or the fact that certain brand might lose credibility and so on. So we don't see this typically unless there's some large economic factor on that. Scenario two is what we would see more typically where part is stressed and it actually could probably run for much longer than it's actually stressed for in a system, for example. And then three is where when we have a very, very optimal understanding of the testing versus the actual utilization, and when we stress a part, we know exactly it's going to fail in 5 years in a system. And this scenario three is what industry have been trying to meet for a long, long time. We think we're mostly in scenario two, where maybe the stressing that we do is it doesn't fully represent the whole lifetime of a part. This is what we're trying to understand with this project, where if we can optimally use a part, maybe longer or understand this reliability better, we can optimally use the part, reduce waste, reduce manufacturing cost because we don't have to keep on replacing the parts or making more parts. And also understand the effect of that on remanufacturing and refurbishing potentially. Okay, any questions on this one?
I don't
Okay.
see any at the moment.
Okay, thanks.
So
then
let's move on.
Okay, so just kind of going back to the overview of the project. So we have two high-level objectives. One is a methodology for selecting electronic components for extended reliability. This includes understanding the reliability, which would be also coming up with a methodology for defining stress testing needed to simulate the extended use of electronic component. And then the other one is, as we mentioned, we have all these kind of groundswell of initiatives that on circular economy, maybe right to repair and other environmental factors. But we don't have necessarily the reliability standards or technical standards to understand successfully understand the extended reliability of electronic components. So we want to, with this project, we want to basically put together a technical background that would allow those standards to be developed down the line. Okay, so if we go to the next one, please. So is not table. So what we're trying to do here is proof of concept. We are now developing standards. This is a proof of concept for actual or extended reliability of electronic components. Also proof of concept for reliability and testing methodologies, and we will not be biased to any supplier. So we don't want to just do tests that would be applicable to certain very small population of the overall ecosystem. Proof of concept for part selection, which is this is not aligned to right to repair or the policy development. This is a purely technical project, although we hope that down the line this will help some of the standard development or policies down the line separately. And then technical assessment of potential fail modes for parts that get extended lifetime testing. and then just the proof of concept for testing those parts. Okay, so go to the next one, please. So we believe that phase one, which is just the methodology assessment, would take us about 8 months. So what we would develop here would be shared with, of course, iNEMI, and then some of the standard bodies to for them to consider developing a standard. But we have 3 deliverables here. Would be the selection of components of interest. How do we select which components we want to stress and test? The methodology for reliability. So what temperature, voltage, acceleration models we would use for this extended reliability. And then maybe a statistical model for sampling for this data collection. So that would take us about 8 months. And then for phase 2, if phase 1 is successful, then this is where we actually collect the data using the electronic components, and we report the data. That would take about a year. But right now we're just talking about phase 1 for this particular call to participation. Okay, any I saw a question somewhere.
Dennis is asking a very specific question through the chat, which I think we'll let the chat see if they have any response for him. I don't know that it's not a question about the project exactly.
Okay.
Any questions about the project or other comments about a project at this time? Okay.
Okay.
Continue.
That's good. So as mentioned, we have a good membership right now for the statement of work, but we would like to get additional members join us. And this is the expertise that we are looking for. We're looking for reliability experts, acceleration models, test methodologies, knowledge of standards, electronic component experts, manufacturing of the parts, understanding the different type of parts available, general industry knowledge, and then systems and products. This would help us kind of gear our stress testing to understand the extended reliability of a system, or what kind of system we should be looking at, and so on. So definitely, if we have these experts on the line, or if you know any of these experts that would be interested in not just a technical project, but also something that would likely benefit the circular economy. I think this is one of the few projects I've seen where you have both a technical side, but also more society kind of approach to it as well. So would definitely appreciate. Okay, so then going to the next one. So benefits, of course, we have a lot of benefits here for the industry. So, I mean, users would be able to assess the real lifetime of a component. We could potentially enable systematic refurbishment, remanufacturing, design for durability, reduce cost and waste of electronic components. We could work with the standard folks to develop this type of information for future use on the standard bodies. We can also look at if we nowadays that we're having a crunch in the electronic environment, how can we extend the lifetime or storage of a part so that we can use it later on, and then create a framework for assessing the full lifetime of an electronic part, and then more flexibility to the supply chain so that we can refurbish or continue to use the part, we don't run into shortages down the line as well. Okay. I think I saw a question somewhere.
Yes, so there's a question from Stephen. Let me find you, Stephen, and I'll unmute you so you can ask your question. And okay, Stephen, you have control of your mic. So if you unmute yourself, you can ask your question.
The topic as presented is extremely broad, and board level reliability or reliability of the individual components really depends on the environment that they're exposed to.
Mm-hmm.
So is this project, have you defined a particular application, for example, automotive or consumer electronics or industrial electronics, to narrow the focus?
Yes. Yeah. So I would say yes. We have a proposal in the statement of work where we have looked at automotive as well as industrial, which I mean typically require a longer lifetime than other areas. So those could be model or kind of proof of concept focus areas for us. But I think the phase one, part of the work in phase one would be to make sure that those are the right decisions and those are the right kind of selections for this project.
Okay, and another question is, we see a lot of obsolescence due to technology advancements, and these advancements occur quite rapidly now compared to what they used to. So we may select a processor for an application that is no longer available 2 years later. Because of various technology advancements. So how do we, how does this project address the technology roadmap and the significant time, shortness of lifetime of many of these designs?
Yeah, that's an excellent point. I think I think there are two aspects of this. One would be, is this really applicable for those very high-end, very fast-moving parts, technologically advanced parts? I would say no. I mean, we haven't made that. I mean, that's part of phase one, I guess, on which parts we would select. We are looking at things like, say, NOR flash memories and passives, O201s, O402s, and things like that have been in the industry for a very, very long time. Those particular parts that you mentioned might not be fully applicable. But even if they're applicable, I think what we're trying to understand also is if we remove those parts and put a new one into the same system with all the other older parts, what would be the effect to those other parts that remain on the system? So we just have to remove that part that is obsolete and then put a new one in and continue using the system. So those are the two aspects of it.
Thank you.
Yeah, your points are very valid, and the team that we form, their knowledge will help us try to, I think, answer and address those questions so that what we're doing is going to be maximum relevance. So please join us and help us answer those questions. Yeah, so Marco, go ahead.
Sorry, I can see from your background, from the questions that I mean, those are really, really good questions and likely a good background for us to join us.
Absolutely. Marco, you had your hand up.
Yeah, so I'd just like here to expand the discussion slightly during the preparation phase. This has been part of the questions from economical point of view, how expensive it would be, for example, to restart production series which has ended 10 years ago versus being able to define that the component does not break out or is not in the phase out condition after 10 years or shorter time instead to 15 or maybe longer time. because its reliability could have been maybe extended or defined to be a bit longer. So to clarify that this is something that we could still work and clarify more in the project.
Mm-hmm. Yep.
Yeah. And just to let you know, Marco has been helping us develop the SOW. He is with PicoSun and has been an invaluable contributor to the work. So he knows of what he speaks. Are there other questions or comments at this point? Okay.
Okay, so this is the high-level schedule for phase 1. So you can see here overall 8 months, and we basically would work in parallel tracks. So most likely we'll have maybe 2 or 3 teams. So one team would basically concentrate on the selection of the parts. How do we select those parts that we want to use? Of course, the teams would be communicating to each other. But then, as we discussed, I mean, would these parts be high-end parts, or would be these older type of parts that could be easily replaced and so on? And then the other team would be concentrate more on the testing and reliability. So this would be what kind of testing would need to take place outside of the standards so that we can understand extended reliability, what kind of temperatures, voltages, whatever needs to be done to understand this extended reliability. I think task 3 is just basically the 2 teams getting together and exchanging information as we come up with decisions on part selection and testing development. Then in the 8th month, we hope to just have a go no go determination for phase 2. And as we progress from maybe 6 months on, we'll just have communications to the rest of the iNEMI and the teams to understand where we're going and what the plan would be for phase 2. So this is high level, the schedule.
Right. And we've included just a touch of phase 2, but at this point, until we know what we discover in phase 1 and what's important, all of the details there in phase 2 are just sort of what we think at this point from previous testing projects that iNEMI has done. But depending on, like I said, whatever we find in phase 1 will influence what is the work that we're going to do in phase 2.
Yep.
So, any questions about this schedule? And I mean, there could be further phases, or there could be a parallel project that develops. It all kind of depends on what we find as we're working through phase 1 and addressing questions and comments that the team come up with. Any other questions or comments regarding the schedule at this time?
Oh, so somebody's asking, when will the project start?
Excellent. Thank you for asking that. Let me get to the next 2 slides and we will tell you. Beautiful. It's almost like I paid you to say that. Thank you for the question. So the schedule that we have here is we're doing the two call for participation webinars today. We're gonna have basically a month-long sign up. So if you're interested in the project, download the SOW and the project statement, read that in some detail. You can ask us some questions. The objective, if you want to join us, you do need to fill out the project statement. I'll talk about that in just a second. So the plan would be to kick off the project in the middle of September. So I say the week of September 12th is what my hope is. And that will depend on, do we have enough critical participation in the project team so that we believe we can cover all the various areas and concerns that we have highlighted in the SOW and touched on here. And the idea is that this is an 8-month project. It would start in the middle of September, and then we would be presenting our findings and or getting phase 2 started in June of next year. If we finish early, great. If we finish a little bit late, That's not ideal, but we have some flexibility if it takes us a little bit longer to get through everything. So to answer your question, the idea is the project would start in the middle of September. And then in terms of joining the project, you can get additional details on the project itself, the SOW, their statement of work, and our project statement at this link, which I have put in the chat window. And I will add it to the chat window again right now so that you can just have a nice live link for that. If you're an iNEMI member, it's a very easy process to join. You download the project statement and statement of work, and you sign the project statement and return it to iNEMI, and then we will execute all of those and send it back to you. If you are a non-member, meaning you're not an iNEMI member, you would need to become an iNEMI member. If you're interested in that and this project, please contact me directly, and I'll put you in touch with the right person at iNEMI to help you do the various paperwork to become an iNEMI member, depending on basically where you're located in the world. We have regional management around the world that is responsible for membership. Are there questions regarding sort of the schedule here and what the process is to join the project? Because this does bring us to the end of the presentation today. Are there any comments? So Juan, any last comments from you?
No, I just want to thank you, Mark, and the team that we have been working together for nearly 3 quarters now, I think, to develop this statement of work. We're still early in the project, so there's a lot of decisions that we need to make, and we definitely would like to get more experts in those areas that we talked about to help us with those decisions and execution of the project.
Thank you. Marco, any last words from you? As I think you were involved in the project quite a long time as well.
Yeah, so as I pointed out, there are, of course, additional benefits to be planned from this project, in addition of getting the standardization, but those will be in the later stages. But at least in the first stage, these testing methods and more practical details will be then looked up. But maybe these kind of economical drivers and the more reasons to be joining to this project and to extend the reliability are something that are still in the project, which we couldn't well enough point out, but by joining the project, more would be found out.
Thank you, Marco. And Kelly, I see you have your hand raised.
Yeah, I just was hoping, Juan, if you could give, like, in an ideal perfect world, your team would consist of the following expertise bullet point list.
Like this one, you mean, Kelly?
Okay, I guess I was looking for one layer of more granularity. Like, you would want somebody, well, maybe this is granular enough. I guess I was thinking, like, again, ideally, what maybe this satisfies it. I don't know. I was thinking there was one deeper layer there of, like,
yeah, I mean, so I
really want somebody who's done the following.
Yeah, I mean, ideally, so we'll have somebody that has done the reliability testing on electronic components, all kinds of electronic components, so that there's a good understanding of how they need to be tested, how long they need to be tested, the conditions to be tested, and so on. So that's that the reliability section means. On the electronic components would be maybe someone that understands what different materials, processes could affect reliability of a part. What are kind of potentially the main players in certain areas or components, and so on. And then finally, on the systems would be somebody that understands how a system is used for, say, if it's automotive, then what temperatures need to be used, what kind of acceleration model needs to be utilized for kind of simulating the system use.
Mhm. Good. And Juan, I was asking because I, in my role at ITC, we have connections with others who have done many years worth of lead-free testing related to the reliability of those lead-free alternatives. And I think some of their expertise may be actually quite useful to this team. And so I guess that's what I should have just asked that. Would that be useful?
Yep.
But I think based on what you just said, the answer would be yes. So thank you for entertaining me and giving that little bit more granularity. Thanks.
Yeah, no problem. Thank you.
And I think as a follow-on to that from Stephen's question, it would be excellent to have a variety of different industries as part of the call to understand, or the team to understand the concerns in the medical field, the automotive field, the aerospace field, the IC field, the telecom field, so that we understand, like I said, a lot of these environments. And then the team may have to make choices. Like I said, we're not going to be able to do everything. That is, like Stephen has mentioned, that's a very broad area to get into. So we'll have to pick what we can do based on the expertise that joins us.
I think Pamela is asking how much time commitment are we looking from members?
Yes. So the plan for generally for most iNEMI projects is usually we have meetings. I'd say at least bi-weekly, 1 hour bi-weekly meetings. Sometimes weekly. It depends on just how the project team is formed and wants to move forward. And then as Juan alluded to, we will be doing a bunch of work in parallel. So hopefully we'll have enough members of the team so we can break into smaller pieces, and those team members can work outside of our regular meetings. So on average, I would expect somewhere between maybe 4 to 8 hours a month of work for each of the team members, including 2 to 4 calls, and for the iNEMI part of it, and then probably 1 or 2 calls, maybe outside of that per month to work on their particular tasks. And then they'll obviously be email. We use Teams to manage everything, so you will be able to share files and do some live editing and things of that nature. And I can set up calls for you, or you can set up your own calls as well if you're part of the team to help facilitate that. So say 8 to 10 hours a month at the higher end, Pamela. Other comments or questions? Okay, so I'm not seeing any more. So I want to thank you all very much for your time. This presentation and recording should be on the iNEMI website, this website here that I've identified in the chat, and I'll put it there one more time by the end of the week. And we hope that you will consider to join. If you've got any questions, please email myself. I'm mark.s@inemi.org, and I will get back to you as quick as I can. So Juan, Marco, Kelly, Stephen, everybody, thank you for your participation and questions today. It's much appreciated.
Thank you.
Thanks, everybody. Have a great day.
Bye-bye.
Bye.
Thanks. Bye.